Alright, so moving into the next section. This is still chapter 1. We've got hardware faults. This is part 1 again. Hardware faults. When we think of causes of system failure, hardware faults quickly come to mind. Hard disks crash, RAM becomes faulty, the power grid has a blackout, someone unplugs the wrong network cable. Anyone who has worked with large data centers can tell you that these things happen all the time when you have a lot of machines. Hard disks are reported as having a mean time to failure of about 10 to 50 years, so that's 5 to 6. Thus, on a storage cluster with 1,000 disks, we should expect on average 1 disk to die per day. Our first response is usually to add redundancy to the individual hardware component in order to reduce the failure of the system, the failure rate of the system. Disks may be set up in RAID configuration. Servers may have dual power supplies and hot swappable CPUs, and data centers may have batteries and diesel generators for backup power. When one component dies, the redundant component can take its place while the broken component is replaced. This approach cannot completely prevent hardware problems from causing failures, but it is well understood and can often keep a machine running uninterrupted for years. That's really good. Until recently, redundancy of hardware components was sufficient for most applications, since it makes total failure of a single machine fairly rare. As long as you can restore a backup onto a new machine fairly quickly, the downtime in case of failure is not catastrophic in most applications. Thus, multi-machine redundancy was only required by a small number of applications for which high availability was absolutely essential. However, as data volumes and applications computing demands have risen, more applications have begun using larger numbers of machines, which proportionally increases the rate of hardware faults. Moreover, in some cloud platforms such as Amazon Web Services or AWS, it is fairly common for virtual machine instances to become unavailable without warning, as the platforms are designed to prioritize flexibility and elasticity over single machine reliability. Hence, there is a move towards systems that can tolerate the loss of entire machines. By using software fault tolerance techniques in preference or in addition to hardware redundancy, such systems also have operational advantages. A single server system requires planned downtime if you need to reboot the machine, to apply operating system security patches, for example, whereas a system that can tolerate machine failure can be patched one node at a time without downtime of the entire system, a rolling upgrade. See chapter 4. I wonder, did I just skip? Okay, so that's the end of that one.